Okay, good evening, students. Hope you can see the presentation. So, regular expression. Today we have to complete the regular expression. So, regular expression represents regular language. In the previous classes, we have seen finite automata, that is the NFA and DFA. Both the NFA and DFA we call generally as finite automata. Okay, and these two are actually representing the regular languages. Okay, NFA and DFA, or in general, finite automata represents regular language. Then another way of representing regular language is regular expression. It is a mathematical kind of expression. Then regular expression, some examples we can see. So the regular expression example. Likewise, suppose 0 star. This one is a regular expression. 0 star is a regular expression. And it represents that 0 star means 0 or more occurrences. Okay, 0 star means when the star is 0, that means the number of occurrences of the 0 is 0, means it is epsilon. Then it can be 0. 1 0 can occur, or 2 zeros can occur, or 3 zeros can occur, like that. Okay. So it is represented, the language represented by every regular expression represents a language. Okay. Every regular expression represents a language. So 0 star is representing a language which is like this: epsilon 0, 0, 0, 0, 0, 0, like that. Any n number of occurrences of 0. One string may contain n number of zeros. The n can be 0 or more. That is the meaning of star. Okay, then 1 or 0. 1 or 0. This is the, I think we missed something in between. Okay. Okay, so here we have to see one more thing, that is the regular expressions. In regular expression, we use only 3 operations. One is the union operation, then the second one is concatenation operation, then the star closure. These are the 3 operations we do in any regular expression. Okay, so union means if we have two regular expressions, we can write R1. R1 is a regular expression, R2 is a regular expression. So we can write R1 plus R2. That means the union. So you please mute your laptop. So all of you mute. Okay. R1 is a regular expression, then R2 is another regular expression. Then we can write, I think somebody is trying to log in. R1 plus R2 means it is the union of these two. So this R1 represents a language L1, then R2 represents another language L2. Then R1 plus R2 means it is the union of these two languages. Okay, L1 union L2. Then concatenation, if suppose R1 dot R2, that is the concatenation. So it is the concatenation of the two languages. Then star closure means R1 star. So this is if L1 is the language represented by R1, then L1 star is the language represented by this one. Okay. So for example, if we say R1 is equal to 0, 0 is representing a regular language, regular expression. Okay, single symbol can represent a regular expression. Then suppose R2 is equal to 1. 1 can also be considered as a regular expression. Okay. So the language represented by this is, suppose L1 is equal to 0. This is the language represented by this regular expression. And for R2 is equal to 1, this regular expression 1 actually represents the language 1. Okay, then when I write R1 plus R2, when I write R1 plus R2, it means that L1, R1 union R2. Okay, the language represented by R1 union the language represented by R2. That is L1 union L2. So this is equal to 0 union 1. Okay, so it's union of sets. So it is 0 comma 1. So it is the meaning of union. Okay. Then concatenation. Concatenation of these two sets. So if I write R1 dot R2 means L1 dot L2, that means 0 dot 1. So it means concatenate every element of the first set with the second set. So it will be 0, 1. The concatenated language will be 0, 1. It is a single element. 0, 1 is a single element. Likewise, then R1 star is nothing but 0 star. R1 is 0, 0 star. Okay. So 0 star means this epsilon or 0 or 0, 0, 0 or 0, 0, 0, any combinations, etc. Okay. So these are the three basic operations we can do in any regular expression. Okay, union, concatenation, and star closure. So this is the expression. 0 star means a set of all strings of the form 0 raised to n. That is, n is the number of occurrences of that 0. Then 1 union 0 means 1 union 0. 1 union, this 1 represents the language set to 1. And 0 represents the language set to 0. And 1 union 0 means this set union of these two sets. So the answer will be set 0, 1. Okay. Then concatenation of 0, 1, the language will be 0, 1. Then 0, 1 star, 0, 1 star, that means 0, 1. The substring 0, 1 can occur n number of times. N number of times means it can be 0, 1, 2 or anything. So when the star is 0, the string is epsilon. Then 0, 1, then 0, 1, 0, 1. Okay, any number of occurrences of this 0, 1. That is the language. Then 1 plus 0 star. 1 union 0 star. That is the string contains, it is the set of all strings made of 0 and 1. Somebody is trying to join. Okay, so this is set of all strings made of 0 and 1. So epsilon 0, 1, 0, 0, 0, 1, all combinations. Then 0, 1 star. So 0 concatenated with the 1 star. Okay, so when we consider the three operations, first highest priority for the star closure. Star closure has the highest priority. Then the next priority is for concatenation. Next is for concatenation. Then the lowest priority is for union. Okay, so in an expression, in this expression, we have two operations. We have a concatenation and a star closure. So this has to be done first. 1 star should be done first, then the concatenation with the 0. Okay. So 0, 1 star. That means 0 is concatenated with the n number of ones. Okay. So when this n is 0, the string will be 0. Then 1, 1, then 2 ones, then 3 ones, like that. Okay, it will go like that. Then the next one is 0, 1, 0 union 1 concatenated with the 0, 0. 0, 1 is concatenated with the 0, 0. Okay, so the first letter can be 0 or 1. Then the next two characters should be 0, 0. So the string will be 0, 0, 0 or 1, 0, 0. So first character can be 0 or 1. So the language is 0, 0, 0 or 1, 0, 0, 0. Okay, so these are the regular expressions. Um, these are regular expressions and the corresponding languages. So in the first column, we give the regular expression, and in the second column, we are getting the different languages represented by this one. Okay, so this expression represents this language. Okay, and this expression represents this language, and language is nothing but the set of strings. Okay, so every regular expression represents a regular language. Okay, these are all regular languages. Okay, now the reverse thing, if a language is given, can we write the regular expression? Okay, so there are some few languages are given here. First language is a set of all strings of zeros and ones starting with the 0 and ending with 1. Okay, so this language can we write the expression. So what the language says, it says that the string, all strings of zeros and ones. So that means sigma is 0, 1. The string can contain only 0 and 1. And it is starting with the 0 and ending with the 1. So if you consider a string, it should start with the 0 and end with the 1. And in between, you can have any string of 0 and 1. Okay. So any string of 0 and 1 is represented with the 0 union 1 star. So any combination of 0 and 1 will be represented with this. Okay. So the first language can be represented like this: 0, 1. Starting with 0, ending with 1. Then in between you can have any combination of zeros and ones. We don't bother what is there in between. We are only concentrating on the first one and the last one. Okay, so we move on to the second language. So first language we have written. Second language is all strings of zeros and ones with the even number of zeros. Even number of zeros. We are not remember. We are not saying whether it is consecutive zeros. We are not saying it should be consecutive zeros. Somewhere zeros should be there, and the number of zeros should be an even number. Okay, either 0 or 2 or 4, not 0, 2, 4, 6, like that. The number of zeros should be like that. So that means we should have if we have a 0, there should be one more 0. Then only it will become even numbers. Okay. And this can be repeated n number of times. This 0 can be repeated n number of times. And one more thing, in between these zeros, we can have any number of ones. We don't bother. Okay, before this one we can have a before the 0 we can have a 1, or after this we can have a 1. Here also we can have a 1. Star means it is optional. If it is sometimes it may be there 0 or more ones, that is the meaning. 1 star means. Okay, so these two zeros are compulsory, and when we repeat the string, this 0 should be repeated. That means when there is a 0, there should be an accompanied another 0 to make it as an even number. Okay, so likewise 0, 0 is mandatory. Then when 1, 0 is there, there should be an accompanied another 0. Okay. Then in between we can have a number of ones. That is the meaning. So it ensures that there are even number of zeros. Then all strings of zeros and ones with at least two consecutive zeros. So here we mention that there should be consecutive zeros. Okay, that means in the string there should be two consecutive zeros, and before these zeros we can have any combination of zeros and ones. After this also we can have any combination of zeros and ones. Okay, doesn't matter. But we should have two consecutive zeros. That is the mean. So this is the and one more thing, this is not unique. This you can write another regular expression for the same language. Okay, so for one language we can have many regular expressions. Okay, for one language we can have different regular expressions, but for one regular expression there will be only one language. One regular expression always represents exactly one language. Then the last one is all strings of zeros and ones without two consecutive zeros. That means there should not be two consecutive zeros. If one zero comes, immediately after that zero another one should come. Okay, so it is like this. This when there is a zero, immediately next to that we put a one. Okay, then it can end with a zero. Sometimes it can end with also zero. That is why we put a epsilon plus zero. Then we can find some other regular expression for the same language also. Okay, so this is what the reverse thing. So if the regular expression is given, we should be able to find out the language. Okay, and if the language is given, we should be able to write the regular expression for the language. Okay, it may come for 2 marks question. Then equivalence of regular expression and finite automata. That means this diagram you should remember. That means this NFA and finite automata and regular expression are interchangeable. So if we have a regular expression, we can convert it into finite automata, and if we have a finite automata, we can convert it back to regular expression. This is why it is called the equivalence. Equivalence means this one should represent a language L1, then this finite automata will also represent the same language. Then only we say that the regular expression is equivalent to that particular finite automata. Okay, that is equivalence. So if we have a finite automata, we can convert that finite automata into NFA into the DFA. Okay, so if NFA is given, we can convert it into DFA. That we have seen how to convert NFA to DFA. And if a regular expression is given, we can convert it into NFA using the method is called the Thomson's construction technique. Okay. Then the third possibility is if we have a DFA, we can convert it into regular expression. That is using Arden's theorem. Okay, so these are the different methods. So if a finite automata is given, we can convert it into regular expression. And if a regular expression is given, we can convert it into finite automata. The methods are available. So we are going to see these conversions. That is regular expression to finite automata and finite automata to regular expression. So first we are going to find out how we can convert a regular expression into finite automata. How to RE means regular expression. How we can convert a regular expression into finite automata. So if the method we are using is Thomson's construction method. So if the phi is a regular expression, it represents a null set. If it is the expression we need to represent, we represent it like this as symbol initial state. Okay, then epsilon is represented like this. The initial state and final state are the same. Only one state is there in the machine, and both final and initial are the same. Then if you want to represent a or 0 or 1, any input symbol we need to represent, we represent it as a transition from one state to the other. Okay, so this is how we represent a single symbol. A single symbol is also a regular expression, so it is represented as a transition. So let us see an example. The construction of the regular expressions to finite automata. So one operation we can do is union. Okay, in regular expression we have one operation union, that is R1 union R2. So how do we represent this R1 union R2? Then another operation is concatenation, that is R1 concatenated with the R2. How we construct the finite automata for this. Then the last one is star closure, R1 star. How do we represent R1 star? So when we do the union, R1 union R2, first we have to draw the machine for R1. So suppose the machine for R1 is M1. Then you draw the machine for R2. So let it be M2. Okay, M2. Then to make it as a union, to make this expression, what we do is we introduce a new state here, initial state. Okay, then introduce a final state here. Okay, then connect this initial state to the initial state of the machine 1 and to the initial state of the machine 2 using epsilon transitions. Okay, and similarly the final state of this machine is connected to the new final state, and the final state of this machine is connected to the final state, the new final state. Okay, so this is representing R1 plus R2, the union. Union will be represented like this. So when we introduce the union, we have to add two new states, one initial state and one final state, and connect these machines using the epsilon transition. Okay, so that is written here. So M1 represents the machine for R1 and M2 represents the machine for R2, and we connect it like this. Okay, then next how we connect the concatenation. So for doing concatenation, first we draw the machine for R1. So the machine for R1, let it be represented with the M1. Then you draw the machine for R2, let it be M2. Okay, R2, M2. Then the final state of this machine should be connected to the initial state of this machine using an epsilon transition. And the final state of this machine will remain as the final state of this. Okay, this is simple. You just draw the two machines one by one and connect the final state of the first machine to the initial state of the second machine. Like this. Then the star closure. For drawing the star closure, first you draw the machine for R1. Okay, R1. This is its initial state and this is its final state. Then you add two new states. One is the Q0 and the other one is Qn something. The final state you add. Okay. So the machine we have drawn. And next step is the final state of this machine should be connected to its own initial state using epsilon transition. Okay. Then you connect this new initial state to this initial state using epsilon transition, and its final state to the new final state like this. Then connect this new initial state to the new final state using epsilon. So these much connections you have to do to implement a star closure. So the final state of this machine is connected. The final state of this machine is connected to its own initial state. Then introduce two new states, one initial state, one final state. Then they are connected like this. Okay. So you have to remember this diagram. Only three diagrams we need to remember. One for union, then concatenation, then star closure. Okay. So union structure will be like this. The machine of first expression, then the machine of second expression. Then they combine them using these two new states. Then concatenation means you draw the machines for the two expressions one by one, then connect them using an epsilon transition. And for star closure, the final state of the machine should be connected to its initial state. Then add two new states, one initial and one final, and connect them with these three epsilon transitions. This is it. Now we can see an example 0, 1. How do we represent 0, 1? That is 0 concatenated with 1. So first we have to draw the machine of 0. So first expression we have taken as 0 and draw the machine for 0. 0 is a regular expression, draw the machine for 0. So how do we represent 0 as a transition? Transition from one state to the other. So initially we are not marking any final state. Okay, we understood that Q0 is the initial state and Q1 is the final state. Okay, for the time being we are not marking the final states. Now we have to represent the machine for 1. Okay, next symbol is 1. So another transition we draw. From Q2 to Q3 we draw. So these are the two machines. This machine represents R1 and this machine represents R2. Now we have to do the concatenation of R1 and R2. Okay, R3 is R1 dot R2, concatenation of R1, R2. That means concatenation of 0 with the 1. So for that, what you have to do? First, we have to draw the machine of 0, then draw the machine of 1, then connect them using the epsilon transition. So it is over. Okay. So we assume Q1 is the final state of the first machine and Q3 is the final state of the next machine. And this final state is connected to the initial state of the other machine. So the concatenation is over. And this one should be marked as the initial state. Okay, that is all. Now another example 0, 1 star. Okay, that is 0 is concatenated with 1 star. Okay, so let us consider 0. You find the regular automata for 0. For single 0, we draw it as a transition from one state to the other, one transition we mark. Then we have to find the 1 star. So before marking 1 star, first we have to draw the machine for 1. Okay, 1 will be drawn like this, 1 as a transition. Now we have to find the 1 star. 1 star means R2 star. So this is representing R2. Now we have to find out R2 star. So to find out the R2 star, what we have to do? The final state has to be connected to its initial state. Then introduce two new states. Okay, we introduce a new state here and a final state here. Okay, then connect this one with epsilon and this with the epsilon. Then connect this one to this. That becomes the 1 star. Okay, so 1 star we have introduced. So I have drawn here already. So I am removing this. Okay, so 1 star is marked. Now we have to do the concatenation of 0 with the 1 star. Okay, that is this machine has to be concatenated with this machine. So the final state of this one has to be connected to the initial state of this using epsilon. So I will draw like this. This is for 0 and this is for 1 star. Okay, and they are connected using an epsilon transition. Okay, so this machine is connected with this machine using an epsilon transition. This is representing 0, this is representing 1 star. Okay, that is all. It is easy, and the same thing can be repeated for any combinations, any regular expressions. Then 0, 1. How to represent 0, 1? So first 0 union 1. So first you have to represent 0. This is 0. Then you represent 1. This is 1. Then 0 union 1. Okay. So for representing 0 union 1, we have to draw the machine for 0, then machine for 1. Then introduce two new states and connect them using the epsilon transitions. That is all. It is simple. It may also ask for 2 marks question. Then the reverse thing, how to construct a finite automata from regular expression. Sorry, the reverse thing. If a regular finite automata is given, how to construct a regular expression. Okay, this is not correct. Construction of regular expression from finite automata. Okay. So it should not contain epsilon transition. If the machine contains epsilon transition, we cannot apply the Arden's theorem. Okay, there must be only a single initial state. Then we can see the equation like this. Okay, so we have to reduce the regular finite automata to this format, and then we can find the example. So take this example, simple one. A is the initial state and B is the final state. Okay, or let it be this is Q0 and this is Q1. Make it as Q0, Q1. So we have to write the mesh the we have to convert it into this format, QRP format. We have to convert, or in the this diagram has to be converted to the equation format. So it is like to write the equations, we have to take Q0. So initially we take Q0. Okay, so there are two states. So for both the states, we have to write the equation for these two states, Q0, Q0, how we convert it into equation. So for that, we have to check how many incoming transitions are there to this, how many incoming transitions are there to this Q0. So this is one incoming transition to Q0, and this is another incoming state transition to this Q0. So this is an initial arrow. So initial arrow is represented as epsilon. So we mark it as epsilon plus, then this arrow is coming from Q1, this arrow is coming from Q1, and the transition label is 1. So it is written like Q1 dot 1. Okay. Q0 the equation will be epsilon plus Q1 into Q1 dot 1. Okay, so the equation for Q0 is this. So we'll mark it as equation 1. Then for Q1, you check how many incoming transition. Only one incoming transition, that is from Q0. So it is marked as Q0 dot 0. Okay, Q0 on 0. So this is equation 2. And you check which one is the final state. Q1 is the final state. So we have to find the answer in terms of Q1 equal to what? That in that format you have to get the answer. So what you have to do, substitute this equation 1 in equation 2. Then we will get Q1 is equal to, what is the value of Q0? Q0 can be epsilon or Q1 dot 1. Okay, dot 0. So instead of Q0, I substituted this epsilon plus Q1 1 dot 0. Then we remove the equation. This will be epsilon 0 plus Q1 dot 1 dot 0. So this is equal to epsilon 0 is equivalent to 0 plus Q1 1 0. Okay. So what is the format? This is equivalent to R equal to Q plus RP, right? That means this is Q, this 0 is Q, and this 10 is P. And what is R? Q1 is R. Okay. So we can write it as, we can write this as P, sorry, QP star. Okay, this can be reduced as QP star. The regular expression can be Q1 is equal to Q is 0 and P is 10 star. Okay, so that means that this FA can be represented with the 10010 star. That is the meaning. Okay, here they have used only the A and B notation. That is why I have written it in the form of Q1. Okay. So any expression you have to reduce the using this expression. And if we have any expression like this, we can always reduce it into QP star format. Then you take another example, this one, Q1, Q2, Q3 like this. So what we have to do first, we start with the initial state. So Q1, we can write it as how many incoming transition? Only one incoming transition. So that is only initial, that is epsilon. So we mark it as first equation. Then you write Q2. Q2 is, it has only one incoming transition, that is from Q1. So it can be written as Q1A. It is second equation. So there is only one incoming transition. Then for Q3, we have how many incoming transition? One incoming, two, three. Three incoming transitions are there. So it can be written as Q1B plus Q2A plus Q3A. Okay, Q1B, Q2A and Q3A. All the three transitions. So this is equation 3. Now the final state is Q3. So we have to find the equation in terms of Q3. That means you have to substitute 1 and 2 in the third equation, because the third equation represents the final state. So what we can do, Q3 is equal to, what is Q1? Q1 is epsilon. So epsilon dot B plus, what is Q2? Q2 is Q1A, and what is Q1? Q1 is epsilon. So this can be rewritten as epsilon A. So Q2 can be rewritten as A. So it is A dot A plus Q3A. Okay. So it is like B plus AA plus Q3A. So it can be considered as, this can be considered as R, then this can be considered as Q, and this as P. So it can be written as, it is in the form of R is equal to Q plus RP. Okay. So this format, if we get in this format, we can convert it and into QP star format. R is equal to QP star format. That means Q3 is equal to, what is Q? Q is B plus AA. Q and P is A. P star. It will be this. So this is the expression for this given. For this FA can be represented with the B plus AA concatenated with the A star. This regular expression represents this FA. Okay. So whenever you get a machine and if you are asked to convert it into regular expression, first you make sure that there is no epsilon transition. If there is any epsilon transition, you have to convert it into NFA. Okay, that means epsilon NFA has to be converted to NFA, then apply the Arden's theorem. Okay, so for applying Arden's theorem, you take every state. For every state, you have to write the equation and mark it as 1, 2, 3 like that. And you check which is the final state, and you have to finally get the equation in that final state. Okay, if Q3 is the final state, you have to get the equation Q3 is equal to like that, and you substitute all the other equations in the Q3. Then we get the answer in the format of R is equal to Q plus RP. Okay, and reduce it into QP star format. That is all in the Arden's theorem. Okay, so that is all for regular expression. Regular expression and finite automata both represents what regular languages. Okay, both are representing regular language. Finite automata and regular expression both represents regular language. Regular language. Okay, and we have to do the conversions. If a language is given, you should be able to write its regular expression, and if a regular expression is given, you should be able to find out the language. Okay, then the regular expression and finite automata are interchangeable. Okay, that means if a regular expression is given, we can draw its finite automata, and if a finite automata is given, we can find its regular expression. Okay, so these are the things we are revising here today. If you have any doubt, you can ask. Okay, we are stopping for today. CO1 is almost over, and somebody asked me whether it is enough for the exam. These are only the basics. Okay, you have to go through the VPPTs that I have shared. You will get more information. These are only basic ideas I am giving. If you understand this much, and if you read the PPT, you will get a better idea. Okay, so all these are basic ideas just to get the pass mark. You don't think that you may get full marks for this one. I conducted this class only for the remedy, that is those who came late in the class or joined the class late, those who did not get the basic idea about the subject. For those only I am giving this lecture. Others, once you understand this much, you go for the tutorial sessions and home assignment, all that shared in your LMS. You try to solve all the problems given in the tutorial and in the home assignment. Okay, once you are able to solve those questions, you can face your exam also well. And then one more thing, I have shared one more document today. We have exempted one topic like pumping lemma and all. So you just study the definition of pumping lemma, which I given in the document. Pumping lemma, the difference between DFA and FA. Those questions you can learn. They may ask in 2 marks question. Okay, there are 6 2 marks question. You can check those things. Okay, if you have any doubt, you can ask, otherwise you can leave.